Hello, today we will learn about system permissions. As we have discussed already that Android is a privilege separated operating system. That is that in the Android, each application runs with a distinct system identity, which are the Linux user ID and group ID. In terms of traditional operating system, each application is a different user of the Android operating system. And just like in the traditional Linux operating system, each user is separated from another user. In Android operating system, each application is separated from another application. So this is the way the Linux, which is under the Android, isolates applications from each other and from the system as well. Besides this isolation, the additional fine-grained security features are provided through a permission mechanism. The permission mechanism enforces restrictions on the specific operation that a particular process can perform. You are already slightly familiar with the permission mechanism because if you see in the Linux, for example, every file has a permissions attached to it. And these permissions show that who can do what with the file. So some may have permissions to only read, some may have permissions to read and write, some may have only permissions to write, some may have permissions to execute as well. So Android operating system is also something similar for applications. Now, in Android, no application by default has permission to perform any operation that would adversely impact other applications or the operating system or the user. For example, let us say reading, writing another application's file or reading or writing users' private data such as contacts. Now, users' contacts without any doubt are a private data for a user. But more than that, another application may also be using users' contacts. So when an application wants to perform any operation on the contacts, it must ask for a permission. That looks very intuitive. Similarly, applications must explicitly share resources and data, otherwise everything is private to an application. And explicit permissions will always be required for additional capabilities. There would never be a case when the additional capabilities are given without explicit permissions. Also, all APK files in Android must be signed with the certificate and the developer must hold the private key of that certificate. So this is the basic security architecture of the Android operating system. So at install time, Android will give each package, and remember the package that we give in the beginning of each app. So Android will give each package a distinct Linux user ID, and this identity will remain constant for the duration of the package life on that device. Now, any two packages cannot normally run in the same process because they need to be isolated. However, if you do want this functionality, then you can set an attribute called shared user ID in the Android manifest file, and then you can have two packages using the same user ID. Later in the course, we will see when this condition is suitable and how to use it. Now, coming back to permissions, there are two types of permissions. One are normal permissions and the other are dangerous permissions. Now, normal permissions are the permissions that cover areas where your app needs to access data or resource outside the app sandbox. That is, it is definitely accessing something outside the sandbox. But whatever it is accessing poses no or very little risk to users' privacy or the operation of other apps. So one simple example is setting the time zone. Now, when it is setting a time zone, when an app is setting a time zone, it is definitely accessing data or resources which are outside the app sandbox. However, as we know that setting the time zone may not have much of impact on users' privacy or the operations of any other application, and that's why we are calling such permissions as normal permissions. Now, if an app declares that it needs a normal permission, the system automatically grants the permission to the app because system is sure that granting this permission will neither impact users' privacy and nor operation of other apps. So let's see the example of some of the normal public permissions which are defined in the Android system. So here is a list of normal permissions given on developer.android.com. So for example, access location extra commands, access network state, access Wi-Fi state, that is whether Wi-Fi is on or not, internet, reordering tasks, setting alarm, setting time zone, etc. etc. And as you can go through the list, you can find out that yes, indeed, these permissions do not seem to be posing or seem to be posing a very little privacy risk. That is why they are branded under the normal permissions. The second type of permissions are dangerous permissions. And dangerous permissions, as the name suggests, cover areas where the app wants data or resources that involve users' private information or could potentially affect users' stored data or the operation of other apps. Let's take an example. Suppose the permission is to read the user's contacts. Now, users' contacts are users' private information, and as I said earlier, another application may also be using it. So not only it impacts the privacy, it also impacts stability of other applications. Now, if an app declares that it needs a dangerous permission, the user has to explicitly grant the permission to the app. If you have an older Android device, older means older than Android 5.0, then the permissions are granted at the install time. However, if you have a newer Android device such as Android 6P or now Android 7, then permissions are granted at the time of running the application. However, in both of the cases, permissions must be explicitly granted. So let's see an example of dangerous permissions. So here are some dangerous permissions: writing to calendar, read contact, write contact, get accounts, write call log, read call log, etc. 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 When we discuss the dangerous permissions, we must also discuss permission groups. So the permission group is simply a group which contains one or more dangerous permissions. Or in other words, all dangerous Android system permissions belong to permission groups. That is, there would not be any dangerous permission which will not belong to a permission group. Now, if an app requests a dangerous permission listed in its manifest and the app does not currently have any permissions in the permission group, the system shows a dialog box to the user describing the permission group that the app wants access to. On the other hand, if an app requests a dangerous permission listed in its manifest and the app already has another dangerous permission in the same permission group, the system immediately grants the permission without any interaction with the user. So let's try to understand with the example that we had just now. Now, as you can see that the permission group phone has many permissions here. Now, suppose in the very beginning, my app requested a permission to read call log. And because by that time user has not granted permissions to any permissions in this particular permission group, the user will be prompted and will be asked to give the yes or no as far as allowing to the permission is concerned. However, once the user has allowed a permission in the permission group of phone, then any other permission coming from the permission group of phone will be automatically granted. So if my app now uses write call log, it will be automatically granted. Because Android assumes that if you are okay with the permission group, then you are okay with all the permissions of that permission group. So here is a slide giving some of the permission groups and the permissions. We have already seen that on this website we can actually get the complete list. Now let us see how do we define and enforce permissions. So if you want to enforce our own permission, that is that we have declared an activity and we want to make sure that no other activity can invoke it unless it asks for certain permissions. So we will have to declare this permission in the android manifest.xml. So in the given example, I have an activity called deadly activity, and I want to say that this is a dangerous permission. So that is the user must explicitly grant permissions to do the work using this deadly activity. In this case, I write a few attributes name. The most important one is the Android protection label, which I mentioned as dangerous. So in this case, now when a user request when the app request access, the user will be prompted whether it wants to grant the access or not. I am also putting it inside a permission group. So if the user has already given permission within this permission group, then he or she is not prompted, otherwise they are prompted. Now, let's move on to working with system preferences. So the first step is to work with system preferences is to add permissions to the manifest. This is for the case when we want to have certain permissions in our app. Suppose we want to have a permission called send SMS. In this case, in my package of let's say this Snazy app, I would like to add a permission of send SMS. Now when my app is running, the user at some point of time will be prompted to allow the permissions for the send underscore SMS or during the runtime, or if there is an older Android device, then during the install time. Now, because the Android changed its method of asking for permissions, that is now the permissions are asked at the runtime instead of the install time. If your app need a dangerous permission, you must check whether you have that permission every time you perform an app operation that requires that permission. That is, if you want to read user's contact, which is a dangerous permission, before reading user's contacts, you must check that you still have the permission from the user. The reason for that is that the user is always free to revoke the permission. So even if your application read the contacts yesterday or used the camera yesterday, you cannot assume that it still has that permission today. That is, you must make an explicit check. Now, in order to check, the Android makes it very easy. There is a simple method called context_compat.check self permission, and using this method you can actually check whether the permission is there or not there. Here's a simple code explaining it. So I run the permission check on this particular activity and with respect to a permission type or permission group, and I store the results. So it is as simple as that. Now let's look at programming code where we are trying to handle both scenarios when the permission is granted and when the permission is not granted. So if we look, check self permission, this activity read context, and this is not equal to permission grant, that is permission has not been granted. In such cases, you may want to show the user an explanations. For example, you may want to tell the user, hey, look, if you do not give the permission, then maybe these extra features will not be enabled. On the other hand, on the right side, if the permission is given, then you may not want to give an explanation to the user because user has already given the permission and you would like to continue with doing the work. Now let's see how to handle the permission. So when your app requests permission, the system presents a dialog box to the user and the user responds. So when the user responds, the system invokes our app's on request permission result method and it passes the user response inside this method. Now, as an application developer, you must override this method to find out whether the permission was granted or not. And this callback is passed the same request code you passed to request permission. So let us quickly see a programming code to see how to get this done in a program. So for example, here we are overriding on request permission result method, which has three parameters: request code, permissions, and grant results. And depending on the request code, that is, I am putting a switch statement and I am then making a case my permissions request underscore read contacts. And then we can say, hey, you know what, if the request is cancelled, the result are empty, do some piece of code, and if the permission is divided, then do some other piece of code. So essentially, you should be able to write the code for the both sides. Now, this was all about permissions. Now let us discuss something very important, which is the best practices of using permissions. Number one, let's go back and think that why do we need permissions? So we need permissions when we want to do something which impacts the user's experience. For example, we may want to take a photo using a camera, or we may want to read users' contacts. Now, in all such cases, we are actually effectively invoking another activity of another application. So when we want to use the camera, there is a camera app which can also be used. So we have two possibilities. Number one, we can ask for permission to use the camera and hope that the user grants the permission so that we can use the camera. Or we can simply use an intent. Like in the last few lectures, we studied that intents, specifically implicit intents, are used to invoke activities in other applications, and these applications may be system applications. So I can use an intent to invoke the camera application. In this case, I will not have to ask for permissions. So just to recap, I had a choice: either ask for permissions to use the camera or use an intent for using the camera. For intent, no permission required. Permission is required. Now let us see what happens when we use permissions. So when we use permissions, our app has full control over the user experience. That is, we will have to design an appropriate UI. So even if we are using camera app, it will run within our UI if we are running it using permissions. Now this may add the complexity, but it also gives you more freedom. Now, if the user doesn't grant the permission, then in that case our application becomes unable to perform the operation at all. So if there is a very critical requirement for some permission and user doesn't grant it, our application will have to stop right there. This is the disadvantage of using permissions. Now let us see what if we use an intent. So if we use an intent, we don't have to design the UI for the operation. So in the intent, if I invoke a camera app, the camera app will be invoked and camera app will have its own UI. So that is the app that handles the intent, provides us the UI, so we do not have to bother about it. However, in some cases, it may also mean that we don't have control over the user experience. So if my app has a certain theme and I use an intent to invoke, let's say, camera, I cannot maintain the same theme when the camera comes up. Now, in this case, if the user doesn't have a default app, then the system prompts the user to choose an app. Otherwise, our default app is used, such as if you are using Chrome browser on the Android, then the Chrome browser will be used. Otherwise, if you have, let's say, Firefox and Chrome, then user will be given a choice. So let's go back to best permissions one more time. Number one, only ask for permissions that you need. So do not ask for extra permissions. Permissions cause privacy worries, and users are very reluctant to provide permissions, especially when the permissions are, let's say, reading the contents, okay, which is a very private information. Similarly, don't overwhelm the user. So if possible, maybe use an intent. If possible, maybe design your application so that you don't need the permission. And if at all you do need a permission, maybe you would like to explain to the user that why do you need the permission. Maybe you would like to say that the permission will allow extra functionality in the application or extra features of the applications. Now, last but not the least, you must test for both permissions model. That is when you get a permission and when you did not get permission. So that is all about system permissions. These are the references from which I have created these slides. Thank you.